So this video is designed to support what we were looking at in class today. I'm going to go through and do each of the classwork examples, and I'll speak through my process as I'm going. I'm going to go across in rows instead of in columns, just because it'll make it a little easier for me to scroll the screen as I work. Problem 1, square root of 60. I look at the square root of 60, and what I'm looking for is the largest perfect square factor of 60. I think about it for a minute, and I realize that the answer is going to be 4. So my first line of factoring will read root 4 root 15. 4 times 15 is 60, therefore root 4 times root 15 is equal to root 60. I look here and I say, oh, I can take the square root of 4, that's 2, so I do it. And I look over and it's like, oh, root 15, what can I do there? 3 times 5? Oh, that's true, but it doesn't help because neither of those numbers are perfect squares. I can't take the square roots of them. They're both primes. And then I realize there's really not a lot I can do with my 15, so I leave it. And now this is a complete problem. The square root of 60 is equal to 2 root 15. 2 root 15 is the simplified radical form of root 60. I'm going to move across and look at the square root of 51. Square root of 51. 51 is an annoying number because it's odd and it's a number that's not in the 12 times tables, so you kind of look at it and suspect that it might be a prime number, but it's not a prime number. It's actually 17 times 3. But root 17 and root 3 are both not going to be factorable because they're not perfect squares and they're not composite numbers that contain perfect squares, so there's nothing I can do with this. So actually this problem, root 51, is kind of a trick. There's nothing I can factor about root 51, so I leave it. It's already factored. Root 121, well, root 121, you should look at it and say like, oh, why'd Dave put that one in there? Oh, it's a perfect square already, so the square root of 121 is 11. Now we get to problem 2 in this order. I know I'm going a little out of order, but root 128, there's a lot of math we can do here because 128 is a number that has a lot of factors. So again, I'm thinking of what's the largest perfect square factor of 128, and I realize that it's 64. And I'm going to write root 64 root 2. 64 times 2 is 128. So then I say, oh, root 64, that's so convenient. The square root of 64 is 8. And I can't do anything with my root 2, so the square root of root 128 is 8 root 2. Moving on. Root 45. Looking at my root 45, and I'm thinking to myself, what's the largest perfect square factor of 45? The answer is 9. So I can write root 9, root 5. And then I say, oh, that's so convenient. The square root of 9 is 3. 3 root 5. Moving on to 10. The question is, what's the square root of 120? I'm going to deliberately choose to do this one a little bit more roundabout, just so that you can see a process that reflects a couple of more steps. So let's say I look at the square root of 120 and I can't think of what the greatest perfect square factor is. It's just not occurring to me. So I'm going to think of what I think of readily, which is 10 times 12. Root 12 times root 10. I force myself out to write out the radical symbol every time because I find that if I force myself to write the radical symbols, I tend not to forget to take square roots. I look at this and I say, well, root 12 and root 10, neither of those numbers are perfect squares, but they are both composite numbers that can be factored, so I'm going to factor them. And I'm going to get root 4, root 3, root 2, root 5. Okay, now I look at these and I'm saying like, root 4, I can take the square root of root 4, that's 2. But now I'm left with this 3, this 2, and this 5. Can I do anything with them? Well, I can't take the square roots of them because they're not perfect squares. And I say to myself, actually what I need to do here is just multiply those back together up to root 30. And then maybe I take a minute here and check, are there any perfect square factors in 30? Are there any factors of 30, which are perfect squares? 4, 9, 16, 25, etc. And it turns out there aren't, so I can stop. That's the answer. 2 root 30 is the answer. Going down to the third row of problems, the question reads, what's the square root of 98? I love a number like 98 because 98 is not in the 12 times table, and you're just not used to thinking about it so much, but it's very close to 100. And then you realize that root 49, root 2, works. And the square root of 49 is 7, so then it's 7 root 2, and we're done. We move on to the next problem. Square root of 24, you think about it, you ponder it for a moment. Oh, and you realize root 4, root 6. 4 is a perfect square factor. Square root of 4 is 2. Can I do anything with my 6? Can't do anything, so it's going to be 2 root 6. 11. Problem 11 reads square root of 90, root 9, root 10. Square root of 9 is 3. Root 10 is just root 10 because it factors into root 2, root 5, but 2 and 5 are both prime numbers, and therefore we can't take square roots of them, so it's not really helpful to factor them. 4. Problem 4 is a lot like the problem right above. This root 147 is a lot like the square root of 98, and that's because root 49 times 3 is 147. Root 49 times root 3 equals root 147. Square root of 49 is 7. The answer is 7 root 3. Next question, square root of 80. Square root of 80, not sure what to do here. I think about it, and then I have like a brilliant brain flash, and I realize, oh man, root 16, root 5. Does that work? 16 times 5? Yeah, that works. And I get 4 root 5 is my solution. 12, square root of 75. This is our last problem here. And I say, okay, it's root 25 times root 3, 5 root 3. And I'm done.